with the trapezoidal rule, then here, maybe it is ending here up to here. Maybe you'll be told to start from here to this value in 4. So if you're told 4 parts, if you divide it into 4 parts, they must be equal. They must be parts or strips with equal interval, isn't it? Are we together? So if you divide like this, you know a trapezium look like this, something like this in that case. So one side is short, one is long, and 90 degrees the height, isn't it? So it means this is like a case of a trapezium which has been turned upside down, isn't it? Are we together? So here we have H, A, B. So you can see these are our intervals. So it is the upper you join with the lower. So the one which is I, you join them like that. You can now see these ones are forming trapezium from the spot like that. You just join the points, isn't it? Like that, you get your trapeziums. This one like that. So you can see there are some parts which are left outside, there are some parts which are left inside. So we are approximating like that. The part which left outside may neutralize with the one which is inside. So it is an approximated value, isn't it? So these trapeziums, if you see, these are the same equal intervals, H, H, H. So a trapezium, how do we get the area of a trapezium? It is a half H into A plus. If this is our trapezium, and the trapezium must be turned upside down. So it means this is our A, this is our B, and this is our A is the first Y naught, isn't it? So you see this is the first ordinate, Y naught. Then the second ordinate is from here up here, the same as this B, meaning this one is our Y1, isn't it? Then this one is the Y, Y3, then that one is the Y. Are we together? So these are the parts. This is the first part A, the first, second part B, the third part C, the fourth part D, or strips. So it is divided into 4 strips. For you to get the area, it is the sum of the area of the strips. You are using a trapezium to approximate, isn't it? So what is the area of this? The area of this first strip, A, is a half H, A plus B, and our A is Y naught, B is Y. See, I found the area of this first trapezium. Then it is plus the area of this second trapezium, it is a half H times your A is now Y1, isn't it? Plus your B is now Y2, the area of a trapezium, isn't it? Then you move to your C, it is a half H times A plus B, isn't it? So this third strip, see, A is Y2, and B is Y3, so it is Y2 plus Y3. Then plus the last strip, it is a half H, A plus B. Your A is Y3, your B is Y4. That is Y3 plus Y4. Then you simplify. You can see a half H is a common factor, isn't it? So you factorize out a common factor. So if I factorize out a half H, what do I remain with? A half H I remain with Y naught plus Y1, isn't it? There will remain with Y naught plus Y1. Then plus, if I remove here, will remain with Y1 plus. Here will remain with Y2 plus Y3, isn't it? Y2 plus Y3, and here will remain with Y3 plus. I will remain with Y3 plus Y4. So if you look at this one, in the trapezoidal rule, the area is given as what? A half H into, you can see Y naught, the first and the last are just 1, isn't it? The first strip, the first ordinate and the last ordinate is just 1. So it is the first ordinate plus the last ordinate, isn't it? Then it is plus, you can see Y1 plus Y1 is 2Y1, isn't it? Y2 plus Y2 is 2Y2, isn't it? Y3 plus Y3 is 2Y, meaning it is first plus last, then twice the sum of the middles. Are you seeing that? Then twice the sum of that. Have you seen how that's come about? Meaning if you want to approximate with the trapezoidal rule, it is the sum of the last ordinates, the first and the last. It is just like saying area is given by a half H into first plus last, then plus 2 sum of the middle ordinates. Have you seen that? Then 2 sum of the middle ordinates. That's why I'm sticking for you to start with Y0, because I don't want to derive Simpson's rule. I want you to use, I want you to devise a means of mastering it. Are we together? Tuko pamoja? Nani, are we together? Good. So in Simpson rule, it is a half edge, then first and last, then plus twice the sum of the middles, isn't it? Plus twice sum of the middle. So what can you deduce from the trapezoidal rule? You can deduce from the trapezoidal rule the number of ordinates. Tell me the number of ordinates here. The number of ordinates are 5 because 1, 2, 3, 4, 5. See there? The number of ordinates are, and how many strips, how many parts do we have there? 4 parts. Part A strip, B strip, C strip, D, 4 parts. Meaning 4 parts simply implies each and every part will have its own interval. So 4 parts means 4 intervals, isn't it? Because each part must have its own interval. Are we together? So what have you seen in trapezoidal rule? The number of ordinates is higher than the strips, number of strips by 1, isn't it? So it means when somebody tells you we are doing approximation with the number of strips, ordinates is not our business. So when somebody tells you to use trapezoidal rule with 9 ordinates, so when they say with 9 ordinates, you will know the number of strips in trapezoidal rule. When you have 9 ordinates, will be how many strips? 8 strips. Are you getting the idea? Meaning the number of strips is what is important to us. But now when they say make ordinate rule with 9 ordinates, will means 9? Are you seeing that? So it means the rule has the relationship between the strips and the ordinates, isn't it? Made ordinate rule, number of ordinates are the same as the number of strips, isn't it? But trapezoidal rule, the number of ordinates are higher than the number of strips by 1 because each and every trapezium is using 2 of them, isn't it? Meaning the middle ones are going to repeat themselves. Are we together? So, this is now the way to master these formulas. Now that I've shown you how trapezoidal and H, you know how H comes. The last interval minus the start interval, then you divide into those number of equal parts, isn't it? So if there are 4 strips, meaning into 4 equal parts, isn't it? Because each part or each strip must have its own interval. See there? So getting H is not a big deal. It is just the whole range divided into the equal number of parts required, isn't it? Good. Now, can we now see how to master the 3 rules together? Because you can see I'm not driving them. I'm not going to derive the Simpsons rule, isn't it? So this is how to master them. Start with the mid-ordinate. So in mid-ordinate rule, the area is given by H into the sum of the ordinates. Are you seeing that? Plus up to the last term, yn. Are we together? Mid-ordinate rule, it is H into the sum of the ordinates. Then when you go to the trapezoidal, rule, you've seen the area, that is the area, is now a half H. Here it is H, here it is now a half. Are we together? Here it is now a half H, isn't it? So it is a half H into, you sum the first and the last, isn't it? So the first is Y0, the last is Yn. Then it is plus twice the ones which are left in the middle, isn't it? So which ones are left in the middle? Y1, Y2, like that until you reach Yn minus 1 because the last one is Yn, isn't it? Are we together? That one you are done with the trapezoidal rule. And in mid-ordinate rule, what do you know? You know that the number of ordinates is equals to number of, in trapezoidal rule, what do you know? The number of ordinates is equals to strips plus 1, isn't it? Because if you have 9 ordinates, it means you have 8 strips. So 9 will only be equals to 9 if you add 1 to strips, isn't it? So, in other words, to make it look neat, you can say, because strips is what we are dealing with, the number of strips is equals to ordinates minus, meaning if you have 9 ordinates, it is 9 minus 1. 9 ordinates means 8 strips, isn't it? Are we together? Because it is the strips we are using to approximate the area. So we make the strip the subject, isn't it? Are we together? Good. Then if you now go to the Simpsons rule, which now a user is approximated with 3 parts tied together, when you get the area using Simpsons rule, it's just a case of trapezoidal, but now it is using 3 division, 2 joined together, 3 ordinates at the same time. If this was started with H, a half H, then this one is now a third H. This one, the first one is edge, trapezoidal is a half edge, then the Simpsons rule is a third. Are we together? Then what were you doing? So you are adding the first and the last. So it is first y naught plus the last y. This is why I'm saying you stick to y naught, because if you put here y1, you are going to interfere with this formula, because I want you to devise a means of mastering. Okay? So it is y naught plus ym, then twice, it is now twice the evens. Twice the evens, y2, y4 in that order. Then plus 4 times the odds. 4 times the odds. You see twice the evens. So for you to note that which one will be twice and which one will be 4 times. You can see, you can master it by saying 2 times 2 is 4, 4 times 1 is 4. So 4, 4. That is easier to master it. Instead of coming and saying twice the odds. Twice the odd plus 4 times the evens. So you can see 2 times 1 here is 2, 4 times 2 is 8. So when you see such case, you see that you confuse the formula. Are you seeing what I mean by devising a means of mastering a formula? Are you not trying to get what I'm trying to say? Devising a means of mastering a formula. So if you try to say twice odd, 2 times 1, 2, 4 times 2, 8. But I wanted them to be equal, 4, 4. So 2 times 2 is 4, 4 times 1 is 4, 4, 4. Are you seeing that? So that is only working when you start with y naught. Meaning when you started with y1, this evens now becomes odd. Are you seeing? And these odds become 1. Becomes evens, and you interfered with the formula again. Are you now trying to get what I'm saying? That is why I'm saying you stick to the y naught. So when you stick to the y naught, you devise a means of mastering the formula when you start with y naught. But this is not a means of mastering the formula when you start with y1. Are you seeing? When you start with y1, you will see this will now change to y3 because y1 is already here. See there? Are you seeing that? Good. So stick to y naught for the first ordinate. Okay? Is that okay? So just like trapezoidal, the number of strips is number of ordinates minus, it is only mid-ordinate rule, whereby, because in mid-ordinate rules, the old rules, ordinates are in the middle. So it must be the same, meaning each and every strip has only one ordinate. That's why they are equal. Only in mid-ordinate rule. Because in mid-ordinate rule is where we have one ordinate in the middle of each and every strip. See there? It's making the number of ordinates to be the same as the number of strips. But these other ones, the number of strips is ordinates minus 1. Are we together there? The number of strips is the number of ordinates minus 1. So in trapezoidal rule, if you are told using 6 ordinates, in trapezoidal rule it means 5 strips, isn't it? In Simpson's rule, if you are told to use 6 ordinates, it means how many strips? 5 strips. And you stick to y naught for you to obey this our method, our criteria, our means of mastering it, isn't it? Twice evens, 4 times the odd. So 2 by 2, 4, 4 by 1, 4. So 4, 4, you see it is always balancing, so that you avoid the idea of confusing a formula in an exam room, isn't it? Because a long table is a requirement in the exam room, but the Simpsons rule is not in the long table. Are you seeing that? You only have the mid-ordinate and the trapezoidal. So you stick to y, you stick to y naught. So those are the 3 methods of integration which will always be there in your exam. One will always come. Okay? One will always come. So if it is not mid-ordinate, then trapezoidal come. If trapezoidal does not come, then the Simpsons come. One of them must come in numerical methods. Are we together? One of them must come. Can we now see an example on how to use this method? Because writing the formula is not using the formula, isn't it? So can we now see how to use this formula? Can we now see how to use this formula? I go to that one I sent you. I sent it in the group. Hello? I sent it. The one to survey. Have you seen it? The one to survey. Oh, I just wrote it numerical methods, isn't it? You've seen the numerical methods. Where does the numerical method of integration start? Number? It starts from number 9. Number 1 to number 8 is Newton-Raphson. I sent it in the group. Yeah, she has it. So look at number 9. Number 1 to number 8 is Newton-Raphson's. Number 9 to number 12 is numerical methods of integration. Then number 13 to 18 is Newton-Gregory, isn't it? So start. Number 9. Use Simpson's rule with 4 strips to evaluate the integral. Use Simpson's rule with 4 strips to evaluate the integral. Use Simpson's rule with 4 strips to evaluate the integral. That is number 9. You are integrating from 0 to pi to d theta over 4th root. You can see there's 4 there, meaning 4th root, isn't it? 4th root of 5 minus 3 over 8 cos cubed theta. You have been told to do it in 6 decimal places. Look at that.